So, what's the secret weapon that gives Python its superpower in data science and AI? You know, it's not really the language itself, but this one single library humming away behind the scenes. In this explainer, we're going to pull back the curtain on the engine that drives pretty much everything, NumPy.
And this quote just nails it. We're not talking about just another tool you can add to your collection. We are talking about the absolute foundation, the bedrock of the entire scientific Python world. It's kind of the silent hero that makes all this modern data analysis even possible.
But, to really get why NumPy is so revolutionary, we first have to understand the problem it was built to solve. And it all starts with a fundamental weakness in regular old Python.
I mean, don't get me wrong, Python is a fantastic language. It's flexible, super readable, easy to use. But the moment you ask it to do millions or even billions of math operations, that flexibility suddenly becomes a huge bottleneck. So what gives? Why is that?
Well, this visual pretty much says it all. Over on the left, you've got the standard Python list. Think of it like a shopping bag. It's super flexible, you can throw anything in there, but it's not very efficient. It's kind of slow. But on the right, you've got the NumPy array. That's more like a rocket, built for one thing and one thing only, pure speed. See, because NumPy arrays hold just one type of data, they are unbelievably fast and memory efficient when it comes to math.
So with that problem clear, let's meet the solution. This is where NumPy, which is short for Numerical Python, steps onto the scene and just completely rewrites the rules for scientific computing.
Here's probably the best way to think about it. NumPy gives Python the engine of a high-performance language, like C or Fortran, but it lets you keep the simple, easy-to-use steering wheel of Python. So you get this incredible, raw speed without giving up the simplicity that made us all fall in love with Python in the first place. And the absolute heart of NumPy is this thing called the ndarray. So here's the secret sauce. Imagine a Python list is like having your books scattered all over your house. To work with them, your computer has to go find each one by one. But an ndarray, that's like having all of those books lined up perfectly on a single shelf. Everything is stored right next to each other in memory. And that perfect organization is the key that unlocks all that amazing speed.
And here is the big payoff. We are not talking about a tiny little improvement here. Operations in NumPy can be 50 times faster, sometimes even more. Something that takes a full second in pure Python can be over in just a few milliseconds in NumPy. This isn't just an upgrade, it is a total game changer.
So, how in the world does NumPy pull off this incredible speed? Well, it's not really magic, though it sure feels like it. It's a really clever technique called vectorization. Let's break down exactly how it works.
Okay, so in standard Python, if you wanted to add two lists with 1,000,000 numbers each, you'd have to write a for loop that goes through every single element one by one. In NumPy, you just add them. That's it. This one simple line of code does the work of that entire massive loop. It makes your code cleaner, way easier to read, and of course, ridiculously fast.
And this is what's happening behind the scenes. When you write a plus b, NumPy doesn't run a slow Python loop. Instead, it hands off that entire operation to highly optimized, precompiled code written in C. It's like it pushes all the hard work down to a much faster layer, while you get to stay in the comfort and simplicity of Python.
And as if vectorization wasn't enough, NumPy has another superpower called broadcasting. Let's say you want to add the number 5 to every single item in a huge grid of numbers. Instead of writing yet another loop, broadcasting lets you just add 5 to the whole grid at once. NumPy is smart enough to stretch that single number to fit the entire array, saving you from writing all that extra code. It just works.
All right, so beyond its incredible speed, NumPy is also this massive, comprehensive toolkit. It's packed with basically everything you'd ever need for numerical work. Think of it as the complete arsenal for anyone working with data.
And it really breaks down into these 4 key pillars. You've got powerful tools for creating and reshaping your data, a huge library of math and statistical functions, a full-on suite of linear algebra operations, and really solid tools for generating random numbers for stuff like simulations.
Getting your data into NumPy is just incredibly easy. Whether you're converting a plain Python list, creating a range of numbers, or setting up arrays of all zeros or random numbers to start a machine learning model, there's a simple, intuitive function just waiting for you.
And right here is a classic example from linear algebra. Multiplying matrix A by matrix B is absolutely fundamental for things like machine learning and physics simulations. Now, in regular Python, this would be a real headache of nested loops. In NumPy, it's just a single command, like np ... and NumPy handles the entire complex calculation in an instant.
Need to actually analyze your data? Well, it couldn't be simpler. Calculating the mean, the standard deviation, the sum, or even just finding the min and max values of huge arrays is all done with these super clean, readable methods. This is the absolute foundation of exploring and cleaning data.
Okay, so we've seen what NumPy is and what it can do, but now let's zoom all the way out and really appreciate its true impact. Because this isn't just another library, it is the bedrock of the entire modern data science world.
I mean, this list says it all. At the very bottom, supporting everything else, is NumPy. Pandas for data wrangling, SciPy for science, Matplotlib for plotting, and even the deep learning giants like TensorFlow and PyTorch, every single one of them is built right on top of NumPy. It really is the universal language of data in Python.
And its reach is just vast. From data scientists cleaning data sets and machine learning engineers building models, to financial analysts running risk simulations and physicists modeling complex systems, seriously, if there's math involved, you can bet NumPy is there, working tirelessly behind the scenes. This quote just perfectly sums up the whole deal. You get the absolute best of both worlds. You get the raw, screaming fast speed of a low-level language, but combined with the elegance and friendly experience of Python. It's a truly remarkable achievement.
So remember, NumPy isn't some dusty old library. It's the active engine that's driving innovation right now, today. It's powering the tools that are changing our world as we speak. Which really just leaves one last fascinating question. With this incredible power at your fingertips, what are you going to build with it tomorrow?